Now, the relation between fractional detuning factor delta and Q naught. The fractional detuning factor delta is given by F minus F naught divided by F naught and by omega minus omega naught divided by omega naught. If you solve this, you can get omega by omega naught minus 1, from which omega by omega naught equals to 1 plus delta. Now, we know that impedance Z is given by R plus J omega L minus 1 by omega C, which we can write, taking R outside, 1 plus J omega L by R minus 1 by omega CR. Here we are multiplying and dividing with omega naught. Here also multiplying and dividing with omega naught, so that there is no change in the final value. That R of 1 plus J omega naught L divided by omega naught R minus omega naught divided by omega naught CR. Omega naught L into R, which is nothing but a quality factor Q naught. 1 by omega naught CR is nothing but quality factor Q naught. And R of 1 plus J of omega divided by omega naught of Q naught minus omega naught divided by omega of Q naught. You can take that outside, 1 plus J Q naught of omega by omega naught, which is nothing but 1 plus delta from this. Let this be A minus omega naught divided by this. So 1 by 1 plus delta. Now, if you solve this, you are going to get R of 1 plus J Q naught of 2 plus delta divided by 1 plus delta. Z equals to R of 1 plus J Q naught of delta. This is the relation between Q quality factor at or Q factor at resonance to fractional deteriorating factor delta. Since delta is very small usually, and at resonance what happens? Omega equals to omega naught. Now, if you substitute this in this equation, this omega equals to omega naught. Omega naught minus omega naught is nothing but 0. 0 by some value is again a 0. Then detuning factor delta equals to 0. If this is 0, this term will be 0. So at resonance what happens? Z will become equals to R. Now let us find the expression for half power frequencies, that is F1 and F2. And we know that omega 2 minus omega 1 equals to 1 by LC. At resonance, omega 2 equals to omega 1 equals to omega naught. So if you substitute this, you will be getting at resonance omega naught square equals to 1 by LC, or omega naught equals to 1 by root LC, or simply F naught equals to 1 by 2 pi root LC. When you compare these two, you'll be knowing that omega naught square equals to omega 1 omega 2, or omega naught equals to square root of omega 1 omega 2. Resonant frequency is the geometric mean of two half power frequencies. Question number 1 here, we know that the bandwidth omega 2 minus omega 1 equals to R by L. From this equation, omega 2 equals to 1 by omega 1 LC. Now you can substitute that here. Then 1 by omega 1 LC minus omega 1 equals to R by L. Omega 1 LC 1 minus omega 1 square LC equals to R by L, or 1 minus omega 1 square LC equals to R by L omega 1 LC. Simply this equation will become omega 1 square LC plus omega 1 RC minus 1 equals to 0. The roots for this, omega 1 equals to minus B, that is RC, plus or minus square root of B square, that is RC square, minus 4 AC, that is AC, is LC, C is 1, divided by 2A. This will be minus R plus or minus square root of R square minus 4 L by C divided by 2L. So when you take the positive sign here, then you will be getting omega 1 equals to minus R positive square root of R square minus 4 L by C divided by 2L. For simplification, you will be getting minus R by 2L plus square root of R by 2L whole square minus 1 by LC. Omega 1 equals to this value. You can substitute this value in this equation, then you can get omega 2 equals to r by 2l plus square root of r by 2l whole square minus 1 by lc. This is omega 2. And you know that omega 1, omega 2 is the half power angular frequencies.